Chapter 13, Video 2. In this video, we're going to talk about axis quadrant determination, and I'm going to go over with you guys how it's used in relation to the previous video. So, understanding and knowing your the correct deflections of what lead you're looking at is very important to understanding how to determine the axis quadrant. So we have the electrical axis, and that is a method of determining the direction of the heart's electrical current flow. The normal heart current starts in the sinus node, which is in the top right of the heart, and it travels toward the left ventricle, which is in the bottom left of the heart. So that arrow would kind of point down and left. In an abnormal heart rhythm, the current may travel in unusual directions. So if you're picturing the heart, the normal arrow would sit at the top of the heart and point down toward the left and kind of go across the heart. So anything that's abnormal would go in a different direction, okay? So axis deviation is what we refer to when the current is traveling in an abnormal direction across the heart. There's different causes of axis deviation. With the normal variant, the abnormal axis may be abnormal for some people. So with a normal variant, that means it may be normal for a certain individual to have an abnormal axis. Okay, so it would not be normal across the board. It's not what we normally see, but it's normal for you. And we'll go over some examples of that too in a little bit. With the myocardial infarction, the infarcted dead tissue does not conduct electrical current. So with the myocardial infarction, the myocardial impulse may travel away or around that dead tissue, which causes a shift in the axis. So it may travel a little bit differently to get around that dead tissue. With ventricular hypertrophy, hypertrophy is overgrown tissue and it requires more current, okay? So with ventricular hypertrophy, the current shifts toward that overgrown tissue, okay? It shifts toward the larger part of the heart because that larger part of the heart requires more current to make the heart beat. Other causes of axis deviation could be an arrhythmia. An arrhythmia can cause axis deviation. Examples of arrhythmias would be a ventricular rhythm that starts in the ventricle and it travels backwards up the heart, okay? With advanced pregnancy or obesity, this physically pushes up on the diaphragm and it can push the heart upward. So with pregnancy and obesity, it may push that heart up and it may shift that axis upward toward the left, okay? So you may see that with pregnancy. And with hemiblocks, these blocks cause the impulses to travel in alternate directions. The block of one branch in the left ventricle causes the impulse to travel in an alternate direction. So you may see right axis deviation or you may see left axis deviation with this. And how do we determine an axis quadrant? How do we know what we're looking at here? And I'm going to go over that with you, and I'm going to give you some practice strips as well. And as we go over these practice strips throughout this PowerPoint, I think it will make more sense to you as we go. So don't get stumped up here with what I'm fixing to tell you, because toward the end of this lecture, I think it will come together. So again, the electrical axis is a method of depicting the direction of the heart's electrical current flow. And how do we determine this? Axis calculation requires a compass, okay? So we have the hexaxial diagram that's superimposed on the heart. In the hexaxial diagram, you're going to find on page 37. So the hexaxial diagram, again, is kind of we use that when we talk about how we're finding which way this current is traveled. In lead one runs right to left, okay? So it runs right to left, and AVF runs up and down. That's very important because we're going to be looking at lead one and we're going to be looking at the AVF lead when we determine our axis quadrant deviation. The axis circle is made by joining the ends of each lines, so the other leads can be separated from each other by 30 degrees. And I think you'll understand, it'll make more sense as we go. I'm kind of just gonna give you exactly what we need, and when we start doing the practice, it will make sense. So looking at we need to determine the axis quadrant. If the QRS in 1 and AVF are both positive, the normal axis would fall between 0 and positive 90 degrees, okay? And if the QRS in 1 and AV are both negative, it's going to fall between positive 90 and positive or equal to 180 degrees, which this will make sense. This will make sense in the next slide. If the QRS in 1 is positive and AVF is negative, it's going to fall between 0 and negative 90. And if it's 1, and if the QRS in 1 is negative and AVF is positive, it's going to fall between negative 90 or positive or equal to 180 degrees. And so let's look at this. This is very important, guys. This slide right here that I'm showing you is super important because I'm going to tell you, it's going to show you exactly how we're going to use this moving forward, okay? So with the normal axis, 0 to positive 90, left axis deviation is going to fall between 0 and negative 90. Right axis deviation, we're going to go over here. With right axis deviation, it's going to fall between positive 90 and positive negative 180, so it's going to fall in here. And then the indeterminate axis, this so-called this because it can't be determined if the extreme left axis deviation or extreme right axis deviation. So it's going to be located between negative 90 and negative positive 180. Okay, so it's going to fall in this area. You need to remember, you need to understand this, and you need to know this table when we're determining axis deviation, okay? And we're going to flip back to this when we're doing some practice strips. But right now I want you to know, you need to know that this is positive, negative 180, 0 degrees, positive 90, and negative. You need to draw you an X, this line and this line. And you need to know negative 90, positive negative 180, positive 90, and 0 degrees. And you need to know that if it falls here, it's indeterminate axis. Here, it's right axis deviation. Here, it's normal axis. And here, it's left axis deviation. So take you and draw you a X across the page. And put negative 90, positive negative 180, and 0 over here, and then label which quadrant. Indeterminate axis, right axis deviation, normal axis falls here, and left axis deviation falls here, and then you'll be able to figure it out as we move forward. We're always going to look at the QRS. We're going to look at QRS in leads 1 and in leads AVF. Remember, lead 1 connects the right arm and left arms, and it tells if the axis is on the right or left half of the axis circle, and then AVF is on the foot, and it tells us if the axis is on top or bottom half of the circle axis. So we're going to use lead 1 and lead AVF. And again, determining the axis quadrant. If both leads in positive 1 and AVF is positive, the axis is normal. You can read through this slide, but I'm going to skip down because I want to show you how to work these out. So you're going to be given a strip just like this, and you're asked to determine what the axis deviation is here. So if you're given a test question and you're asked to determine what is the axis deviation, when you look at this, what is the first thing you should know? The first thing you should say is, I know that I have to use lead 1, and I know that I have to use AVF. Now, when I use these, that means this is lead 1, and this is lead AVF. I know these are the two that I'm going to be working off of. So here I see lead 1 has a positive deflection and AVF has a negative deflection. So lead 1 is positive, AVF is negative. I'm going to flip back here and I'm going to go, okay, lead 1. Lead 1 is negative, okay? So it's negative. This is my negative side. I know my negative travels to the right. So I'm going to put me a mark here. AVF is negative, okay? So when I see that AVF is negative, I know that this is negative. This goes up because my negative numbers are on they're on the top end of the stick here, okay? So we have positive and then we have negative. When I look at lead 1, I'm looking from left to right. This is the line that I am assessing with lead 1. So lead 1, this is the negative side, okay? We're going to go to the right side for negative. In AVF, it's negative, so I know I have to go up to get to the negative. So when I look at this, I've got a mark here and a mark here. So this falls within left axis deviation, okay? So let's scroll down. Let's look at another one. This is lead 1, and this is lead AVF. And in lead 1 and in lead AVF, these are both positive deflections. Okay? We have lead 1. We're going to the 0. And then we have positive 90. Okay? So we have a positive. We're going positive. So this is going to be a normal axis. I just want to make some clarifications. I'm not sure. I may have gotten tongue-tied on that last slide. So just to make sure we're on the right page, and we're thinking the same here, I'm going to go over strip 1 again. Lead 1 is positive, AVF is negative. So with our positive, we're going to travel to the right. So this is positive, we're going to travel to the right. And I think I may have said negative. And then with AVF being negative, we travel up. So that gives us left axis deviation on that first strip that we did. So this one is left axis deviation. And then going back to strip 2, we see that we have a positive lead 1 and we have a positive AVF. So we're going to refer back to that slide. We're positive, we're traveling to the right, and we're going down. So this is normal axis. And then moving forward, I'm going to keep flipping back to slide 15, so y'all bear with me. We have a negative deflection in lead 1, and we have a negative. This is lead 1, it's negative, and then we have a negative deflection in AVF. So let's go back up. And when we have that negative deflection, we're going to travel to the left, to the negative side over here. So we're going to put a mark here. And then we're going to travel up here because it's negative in AVF. So this line represents the lead 1. This line represents AVF. So left to the negative. So we're going to put a mark here. Up is negative. So this is an indeterminate axis. Strolling on down to strip 4, we have a positive in lead 1 and a negative in the AVF. So let's go back to slide 15. With strip 4, we have that positive in lead 1 and we have that negative in AVF. So if we're going positive here, we're going to travel to the right and put a mark here. And if we're going negative, we're going to travel up. So that's going to give us a left axis deviation. In strip 5, I'm just going to stay on this map. Lead 1 is negative and AVF is positive. So with lead 1 being negative, we're going to go here. And with AVF being positive, we're going to go here. And it's going to give us a right axis determination. But that is it for this video. You can work the questions out. And if you have any questions, let me know.